All right, let's talk about one of the biggest decisions you have to make in AI architecture. Are you going to use RAG or are you going to fine tune? Because getting this wrong isn't just a small technical error. Honestly, it's one of the fastest ways to absolutely incinerate your budget. So I'm just going to ask you straight up. Are you burning money on fine tuning right now? Think about it. Because an incredible amount of time, cash, and really precious GPU cycles are being wasted on this exact problem, and it's all because of one single stubborn myth. So let's just dive right in and bust the single most expensive myth floating around in AI engineering today. And here it is, the big one. The idea that fine-tuning is how you teach an AI new stuff. You know, how you upload your company's entire knowledge base right into its brain. Now look, this idea feels intuitive, it kind of makes sense on the surface, but it is fundamentally deeply wrong. And it is costing people a fortune. The reality is actually this simple. Fine-tuning is for changing a model's behavior, not for cramming in new knowledge. It's about teaching it a new skill, or a different tone of voice, or a very specific way to format its output. It's all about changing how it acts, not what it knows. And that distinction, that's the key to everything. To make this crystal clear, let's use a really simple, but I think pretty powerful analogy. Just imagine your large language model is a doctor. Okay, so fine-tuning, that's like sending your doctor to medical school. It is an expensive, super time-consuming process where they learn the core skills of their job, how to diagnose an illness, how to talk to patients, the general patterns of medicine. This is a permanent change to their behavior. RAG, on the other hand, is like handing that fully trained doctor a specific patient's chart. It gives them the immediate, up-to-the-minute facts they need to do their job right now. It is cheap, it's dynamic, and you can update it in a second. I mean, think about it. You would never send a doctor back to 4 years of med school just to learn about one new patient's symptoms, right? Of course not. Okay, so with that analogy locked in, let's move from the concept to a real, practical tool you can use on your very next project. Let's walk through the decision-making flowchart. This is it. This is the first, and honestly, the most important question you have to ask yourself. Is the problem you're seeing with your model a gap in its knowledge or a gap in its behavior? Because your answer is going to send you down one of two completely different roads. A knowledge gap is pretty much what it sounds like. The model just doesn't know a specific piece of information. For example, it has no idea what your company's brand new refund policy is or the technical specs of a product you just launched. The information is factual and it's external to the model. Now, a behavioral gap. That's a totally different animal. Here, the model might know all the facts, but it just isn't acting the way you want it to. Maybe its tone is way too casual for a legal document, or it keeps failing to structure its output in perfectly valid JSON every single time. This isn't about what it knows, it's about its performance and its style. Okay, so here is the decision tree in all its glory. And you can see it all starts with that one simple question. Is it a knowledge gap or a behavior gap? If your answer is knowledge, look at that arrow. It goes straight to RAG. End of story. But if it's a behavior problem, then and only then do you start to even consider fine-tuning. And even then, you've got to ask if you have enough examples. But the main takeaway is written right there at the bottom. And this is the single most important mantra to burn into your brain from this whole explainer. RAG is for content, fine-tuning is for form. Simple as that. All right, enough with the theory. Let's make this really tangible with a case study. We're going to meet the engineering team at a fictional company called Skystream Airlines and see exactly how they use this framework to make the right call. So imagine you're in their conference room. On the whiteboard, the Skystream team has mapped out two totally different problems they need to solve using AI. One is a super simple policy update, and the other is a really gnarly legacy system integration. Let's break them down. First up, scenario A. The marketing department just decided to change the price for a standard checked bag. This is a textbook example of a knowledge gap. The model's core behavior, being a helpful chatbot, is perfectly fine. Its information is just suddenly out of date. So what's the fix? Well, the fee changes from $30 to $35. The engineering team goes into their vector database, finds the policy PDF, and changes the number. The entire process takes, 5 seconds? And now, the next time a customer asks about baggage fees, the RAG system just pulls the new correct price. Can you even imagine the insane waste of retraining and redeploying a whole fine-tuned model for a $5 price change? It would be crazy. Okay, now for the much more interesting problem, scenario B. Skystream, like a lot of big companies, is still running on an ancient meme frame system. And it has its own bizarre, totally proprietary query language. This, my friends, is a behavioral gap.
I mean, just look at this syntax. Get dis, pnr, then var, ilk1. What even is that? It's not SQL, it's not Python, it's just mainframe weirdness. And here's the problem. A really powerful model like GPT-4 is actually too good. It's been trained on so much proper, clean code that it will often refuse to generate this junk. It tries to correct it into something that makes more sense. The model's behavior is the problem.
So what's the solution? This is where you fine-tune. But notice, they don't use some giant, expensive model. They take a smaller, super efficient model like Mistral 7B, and they train it on over 5,000 examples of English questions translated into this weird mainframe code. And this just brilliantly proves the point. The result is a model that has learned a new skill. It's learned the grammar of a new language. And here's the kicker. It doesn't need to know today's flight schedule. That's a knowledge problem, a job for RAG. It just needs to know how to speak the strange language of the mainframe. So the case study just proves our principle perfectly, doesn't it? The baggage fee was a content problem, solved instantly with RAG. The mainframe language was a form problem, solved by teaching a new skill with fine-tuning. It just all comes back to this one simple idea. RAG for content, fine-tuning for form. And that brings us to the final question, the one I want you to take back to your own team. Take a hard look at your current AI systems. Where are you using an expensive, complicated fine-tuning process, a behavioral solution, when all you really have is a simple knowledge problem? Where can you swap out all that complexity for the beautiful speed and efficiency of RAG? Finding the answer to that, well, it might just save you a whole lot of time and a whole lot of money.